Hello everyone, welcome back to Clear Creek Solutions hydrology education videos. In this video, it's another FE exam review problem. We'll be calculating the circular pipe head loss using the Hazen-Williams equation. I am your instructor. Just a quick note on Clear Creek Solutions. We develop software for hydrologists around the world. We do hydrology education and clinics such as these videos. And we do projects that require stormwater analysis and facility modeling. Well, let's get into the problem. Here's the problem statement. Find the head loss in a pipe that is 200 feet long, has a Hazen-Williams coefficient of 131, a diameter of 1.5 feet, and a velocity of 2 feet per second. The answers are given below, A, B, C, D. We have to find the answer here. So our first job here is to read the problem statement and find out what is given, what do we need to find, and what equations are we going to need to use to get that to find what we're looking for. So here we're given the length of the pipe, the Hazen-Williams coefficient. We're given the area sort of indirectly through the diameter, and we're given the velocity. Now we need Q for the equation we're going to use to help find the head loss. So here's the equation we're going to use. This is taken right from the FE manual, which is what you're going to use on the FE exam. Head loss equals 4.73 times the pipe length over the Hazen-Williams coefficient raised to the 1.852, the pipe diameter raised to the 4.87, and the flow raised to 1.852. So that's our equation. We were given the length, we're given the Hazen-Williams coefficient, we have a diameter and a velocity, but we don't have Q. So we're going to need to find Q through a different equation. And we're going to use Q equals V times A, use information given to find flow Q, then plug it into Hazen-Williams equation, then we can find the head loss. So Q equals V times A. We can find A, which is measured in feet squared. We have the diameter, which is 1.5 feet. So the area can be calculated at pi d squared over 4. And the velocity that was given was 2 feet per second. So we've got 2 feet per second times the area, pi d squared over 4, which is 1.5 feet. That gives us a Q of 7.1 feet cubed per second. So now that we have that Q value, we can plug it into the full equation and find the head loss. So we got 4.73 times the length, which was 200, the Hazen-Williams coefficient of 131 times 1.5 raised to the 4.87. That was the diameter. The Hazen-Williams coefficient is raised to 1.852. We're multiplying that by 7.1 raised to the 1.852. And we get a head loss of 0.594 feet. Now, on the FE exam, you're not always going to have the answer that's exactly like your answer that you got. But the closest one is obviously 0.6, so the answer is C for this problem. If you're struggling with the process for solving FE exam problems, especially for water resources problems, you might want to download our FE exam water resources guide. It's in the link below. It's 100% free, and it'll give you a process, a set of equations, and a descriptions for these water resource type problems and how to solve them. So click the link down below, get that guide for free, and we'll see you guys in the next video.